Welcome to MrCScience.com's video on speed and velocity. We're just starting our physics journey here, so we're going to get a little bit into, you probably understand what speed is, you maybe understand what velocity is, but we also want to get into the nomenclature we use because we're going to use it throughout the course. As usual, you should have your book handy. If you don't have it, pause the video, go and grab it. So what we're going to do is we're going to talk about speed and velocity. Before we can talk about speed and velocity, we need to talk about distance and displacement. So, okay, let's say here, let's scroll down a little bit, give ourselves some room to write here. Okay, so let's say we got a point here, point A, and we got a point here, point B. Okay, now the straight line between point A and point B, which I cannot draw to save my life, let's do it this way. Boom. Boom. Okay. Okay. That straight line is in one instance distance, and another instance displacement, how much we've changed. But we can say that's city A and city B. We're going from city B back to city A. Now the roads rarely go in a straight line unless you live in North Dakota. So roads go over here and back here, across over here, there, and we get there. Okay. So following the fatter line, the roads, that is our distance. Distance is often listed as a lowercase d. The smaller line here, this is our distance. The skinnier line is our displacement, often listed as lowercase x. So distance versus displacement. What's different here is this is scalar, and this is a vector. So in scalar, we don't care about direction. So all you do is you straighten out this line, you get a length, and you figure out what the distance is. You don't care that you've changed directions along the time. Vectors do care. So our displacement is a vector quantity. It cares about direction. So even though we did all this traveling, our actual displacement was only from here to here. So that's kind of scalar versus vector and d versus x. So that brings us to speed versus velocity. So let's start with speed. Speed equals, here in your book it lists it as delta d over delta t. Okay, a couple things here. D we talked about is distance. No, I'm not going to try to write that out. T, lowercase t represents time. That's going to be constant throughout our entire book here. So lowercase t represents time. This delta represents change in. So let's take our x here. What we want to do is we want to take, so our delta x, our change in x, is equal to our destination A minus our beginning. So often we'll consider our beginning is 0, so that means just our A is our distance. So okay, so speed is change in distance over change in time. So our distance wandered all over the place. Velocity, V, equals change in displacement over change in time. So velocity is a vector. It cares about direction. So our change in our displacement over change in time. So you may have driven 60 miles an hour to get to A, but with all the variations and things, your actual velocity may have only been about 45 miles per hour. So to get from point B to point A. So that hopefully makes some sense to you. We're going to use this again and again. Now, I pulled both of these, v equals delta x over delta t and speed equals delta d over delta t, from your book on page 9. You'll notice something interesting on page 9. Both of these formulas are in a salmon color. What that means is you need to know these. So you're going to need to know these formulas going forward, and actually we're going to use them a lot. So if you don't know them already, you should memorize them. But we're going to use them again and again. So if you have any questions about that, feel free to contact me at Mr. C at mrcscience.com. Thank you.